Welcome to myprojectbazaar.com. Our product title is Power Energy Minimization Techniques for Variability where High Performance 16nm 60 SRAM. Now we are going to discuss about our product abstract. Our product main objective is a low power high speed circuit design difference from application to application. In case of battery operations, portable systems such as cellular phones, laptops, primary goal is to keep the batteries. So we are going to that minimization, power and energy minimization is critical concern of the battery lives. So we extend our previously proposed hybrid analytical on the model for the minimization predicting the delay and delay variability for SRAMs. So we are going to 6 transistor SRAM designing in the Tanner designing tool and to minimize the predict the power and energy variability of 16nm 60 SRAM under the influence of the three major types of the variations: fabrication, operations and implementations. So we are using the power calculation and frequency calculation in the T-space tools optimizations and comparing the range of the feasibility architectures subject to the intervals and process operation variations. And then the process variations have become the significant and the result of the continued technology scaling those deep subsequent regions of the technologies. And while those numerous of the studies have been conducted of minimum SRAM energy consumptions mostly at various older technology nodes with only one or two specifications of the techniques deployed in the designs, research and variation mitigations with the different goals. And then the potential and the partial completely neutral position impact each and other on the worst case of the scenarios even the count with the SRAM cells layout and improve the function's performance. Another technology suggests the winding the bit lines reduce the current densities as discussed in the design process. The simulation adaptive effective mitigations techniques process variation environmental factors aging effect in the SRAM's designs typically assume the God bending the method of the labels consistent components over the operation fabrication cons. Now we are going to discuss about our product flow diagram and architecture diagrams. So now is in the architecture diagram. So we are initially the designing the 60 transistor SRAM architectures and then read bit lines functions and the single bit cell designs, and then output to the storage results, read write and performance results. Out we have give the input and out to get the control panels of the bitwise and voltage and pulse whatever. And the feedback controller systems is controlling the PMOS and NMOS, and then we are getting the storage result in the RAM. How we are getting the result of the depend on the input functions. And then we are going to the flow chart. So we are giving the input a bit for the whatever we are giving the clock voltage source and then bitwise. So whatever the pulse also. We are designing a 60 SRAM group of the functions, and then we are give the input for the RBL read bit line, right, for WBL write bit line and the write bit read line and the read bit lines. So whatever the functions give them path and the get read path get the bit processing and select the selection bit the process in the selection bits after selections process in the feedback controller systems. The variation mitigation of the SRAM energy consumptions whatever that all these times effectively the techniques of the process holding the process, and final output of storage the data bit. And then we are getting the performance analysis we are using that power and frequency analysis that same time the energy also. So whatever the we have made multi-source systems vendors respectively variations can stream the device the aging the predicts the performance and power consumption variations. Now we are going to discuss about our running procedure. This is edit. This is Dana designing tool. I have this is designing the process circuit schematic diagrams. So how to we run that and how to simulate the process settings. So now first I have done the designing process. After we are going to the set up the simulation process. Here the stop times 200 nanoseconds, the maximum time step 1 nanoseconds, the print times 0, the print time setup uh, so 1 nanosecond. So what we have the click and the tangent for analysis and double click the process settings the process. So we have to give and OK. After going to start simulations, here I am going to run the process. So then automatically we have opened the T space. The process is done after the successfully done. W edit waveforms was the process of the output processor. So this split expand the chart. So this is the process. So what are we are giving the process WBL and WRBL frequencies. This is what are the enable functions the process is enables. After this is the input, this on WBL the bit is written. After that we are giving that process is stable enable functions, and then this time is feedback controllers is also getting that. And after that designing the process, we are going to the how to calculate the power flows. Here the file and export a spice, export the file. We have dumped the cell files. Export the file, the cell 0. So this is our main project. This cell is selected and save it and export it over the file. After we are going to the open the file and then we are going to open the cells. Here what other we need, select one, like we have calculate the power. So P, and then what functions we need to, for example this process we need, and copy, then just run it that. So this is the our calculation of the power this space. This is the voltage and this is the power calculations. So performance we decrease what are the levels we get the give the input and output.